All right, good afternoon, everybody. So this project initially planned for a short period of time, went on uh, longer than expected. COVID was one of the factors, but we're finally wrapping it up. And we already have a draft final report. And this is essentially a summary of that report. And we're hoping to submit the revised final report by the end of this month. So you can send your questions, comments directly to me or to Zach, who can forward them to me. And that way we can produce a report that takes into account your comments. All right, our objective in this project was to estimate the response of ozone to NOx and VOC reductions from different inventory sectors, with the goal of identifying the optimal ozone mitigation strategies for non-attainment and maintenance areas in the LATCO region. And the 4 questions that you see here are paraphrased from the RFP. How the ozone concentrations at different receptors respond to NOx, VOC, or NOx and VOC combined emission reductions. And we want to answer that question looking at a wide spectrum of reductions ranging from 10% to 100%. The same question for emission reductions from different sectors. So the first one was total anthropogenic emission reductions ranging from 10% to 100%. So of course, the reductions from different sectors will be a much smaller fraction of the reductions addressed in the first question. And then the third question is which combination of NOx, VOC, and sector has the largest impact on peak ozone? And the fourth one is what periods in the dial are most effective for sectorized emission reductions? Now, the approach we have taken was to use the ChemX model equipped with HDDM to simulate the first and second order sensitivity coefficients of ozone concentrations to various emissions, NOx, VOC, and those emissions from different sectors. And then using those sensitivity coefficients, we build reduced form models, and we use those models to assess how ozone concentrations respond to changes in total anthropogenic emission reductions by constructing ozone isoplats. And then we evaluate the impacts of sectorized and time split emissions. So time split is, when we look at the different periods in the dial. And then finally, to assess how ozone concentrations respond to sectorized VOC or NOx emission controls for achieving a desirable design value. So what is HDDM? You are probably familiar with the brute force sensitivity analysis. So on the x-axis, we have emissions. Those may be NOx or VOC. And then on the y-axis, we have the concentrations of ozone. Now, in the brute force, we do two model simulations, one at the level of EA, at this level of emissions, and then we do a second simulation at a reduced emissions level. And then from that, we calculate the response of the ozone concentrations by taking the difference between these 2 points and then dividing it by the reduction in the emissions. Now, there is also a DDM, which only involves the first order derivative of this black line here. That's the ozone response function curve, which we don't know. We're trying to determine that. But what's interesting about DDM is that you only do one simulation at this emissions level, EA, and you calculate the derivative of this curve at that point, which, if you recall your calculus, is the slope of the tangent at that point. And then, for further reductions, you extrapolate along that curve. For instance, if you extrapolate all the way to this level of emissions, then you're gonna estimate a reduction that is actually far less than what the brute force method told you. So DDM is only first order accurate, and as I have illustrated in this example, it can involve a large error. But with HDDM, we also involve the second derivative at that point, at this level. There's still one model simulation involved, but with the help of the first derivative and second derivative, we are able to determine the curve, this yellow line, which is more in line with the black curve, which we're trying to determine. So the estimate that you make with HDDM is more accurate. And actually, I can argue that it's going to be even more accurate than the brute force sensitivity method. So now this is the domain, which we have covered with what was the resolution, Yongta? 4 kilometers. Sorry, I have something covering the title here. All right, which I was able to get rid of. Good. So this is the 4 kilometer modeling domain. And we're going to look at all these non-attainment and maintenance areas in this domain. Now, the modeling episodes, we selected 3 episodes by looking at the ozone heat map. And I'm going to use the shorthand MDA8 for daily maximum 8-hour average ozone concentration. So this is an example from the June heat map. So you're looking at all the days, and for all the non-attainment and maintenance areas, as you can see, we have periods that are red. Those are ozone concentrations, really high ozone concentrations, and then oranges and yellows, indicate high ozone concentrations. So we looked at the entire summer of 2016 and selected these 3 periods since they coincided with the higher ozone days. Just a little bit of model performance. We have a full suite of performance evaluation charts and maps and tables. So I'm just going to give you a snapshot. This is the episodic ozone performance, what you see in the table for days that had an MDA8 ozone larger than 60 ppb. So you have a column for observations, a column for simulations. The number of pairs, now we had more days in June with concentrations higher than 60 ppb. So as you can see, the bias was, the model was low biased in June by about 8%, high biased in July and August by 6 to 7 and 4%. And the error on mean, these are the normalized mean bias and normalized mean error. And the error was about 10%. So we have scatter plots like these, where we plot the model simulation on the y-axis and the observation on the x-axis, and draw these regression lines, look at the slopes and correlation coefficients. So this is just an example for Chicago. So each point is essentially a day that we have simulated. And this is multiple sites in the Chicago non-attainment area. On the right, we have a spatial map showing the ozone concentrations, MDA8 ozone concentrations that we simulated for June 10th. And the dots that you see are the observations. So we overlay those on top of the model simulation. Of course, there are some good agreement points, and then there are some, with bad agreement, such as this point here, when the observation was larger than 70 ppb, but the model only simulated something like 50 to 55 ppb. All right, next, let me summarize the sensitivities that we have modeled. So the first 3 were sensitivities to total anthropogenic emissions. We have done that at 3 different levels of base emissions. We did it at 100% level. Now, since reductions in total anthropogenic emissions are large, even with HDDM, we can incur a large error. So we did a second simulation at the 50% of the emissions level, and then a third one at the 10% emissions level. So with these 3, we are hoping to get you that entire spectrum from 10% to 100% reductions. So to do that, we actually combined the results from these 3 simulations that we're going to call A for anthropogenic 100, A50, and A10. And then we did sensitivities to emission sectors. all these sectors that you see. But those simulations were all done at the 100% emissions level. Now the HDDM parameters, I'm going to refer to as N. N is the first order sensitivity to NOx emissions. V is the first order sensitivity to VOC emissions. And N is the second order sensitivity to NOx. PV, second order sensitivity to VOC. And NV is actually a cross second order sensitivity to NOx and VOC emissions. So it essentially tells you what happens if you are reducing NOx and VOC concurrently. And then looking at these periods in the dial, we have 6 periods, early AM from 6 to 9 Eastern Daytime, and then late AM 10 to 12. Early PM is 13 to 15. Late PM 16 to 19. We have an evening 20 to 22, night 2300 to 5 AM the next day. So we are simulating sensitivity to NOx emissions from these 5 sectors, and the sensitivities to VOC emissions from these 6 sectors. Now, these simulations were only done for the short high ozone episodes, so it wasn't done on the on the full length of episodes that I have mentioned earlier. All right, a little bit of explaining before I show you the results. So how are we going to interpret these first and second order HDDM sensitivities? So first of all, we look at the first order sensitivity of ozone to either NOx or VOC emissions. If it's positive, it can be either like this or like that. Now the second order sensitivity, or the second derivative, also known as the curvature, will tell us which one of these we are looking at. If the second order derivative is positive, that implies a curve that is concave up. If it's negative, it's concave down. So let's study an example for this positive slope, negative curvature case. So positive first order sensitivity, negative second order sensitivity. So the curve is concave down with the slopes, positive slopes, decreasing. So if you are at this level of emissions, and if you start reducing your emissions, then the corresponding ozone concentrations will decrease. And as you reduce more and more of whichever emissions you're reducing, you're going to see a bigger and bigger reduction in ozone. So the benefit is actually increasing in this case. In this case, it's the same thing. Reduction of emissions reduces ozone, but the benefit is going to reduce with further emission reductions. If the slope is negative on the first derivative is negative, or first order sensitivity is negative, so those are disbenefit cases. When you reduce the emissions, you're going to see an increase in ozone. And if the second derivative is negative, which is this case, with the concave down, slopes decreasing, you're going to see a reducing this benefit if the slope is positive. If the slope is negative, but the second derivative is positive, a concave up case, then the disbenefit is going to increase with further emissions. I hope this is clear. I can take questions at this point because this is going to be important. All right, I guess it's clear enough. So let me show you this example to illustrate. Now, this is the sensitivity modeling results from the A100 case. So we've done the modeling at 100% of the total anthropogenic emissions. And this is just for one day, which is June 10th. So the first order sensitivity to NOx, as you can see, is mostly positive over the domain. So that, and the second order sensitivity to NOx, which is the curvature, is negative mostly over the domain. So positive slope, negative curvature, we are looking at this case. So for most of the domain, reductions in NOx will reduce ozone, so you have a benefit. And the benefit is actually increasing as you reduce NOx emissions more and more. So each additional ton will give you an extra benefit. Now, there are some exceptions, as you can see, right off the coast of Chicago over Lake Michigan. There is an area of negative first order sensitivity to NOx. And actually, right along the coast, the second derivative is positive. So we are looking at this case down here at the lower right. So we have a negative slope with a positive curvature. So you have a disbenefit of NOx emission reductions, and the disbenefit is increasing with further NOx reductions. Now notice that on the cross derivative, second derivative, with respect to NOx and VOCs, the same area has a negative second order sensitivity. So what that means, since it's the opposite sign of this second derivative, which increases the disbenefit, that means if you are reducing VOCs at the same time with NOx, then that this benefit will, or the increase in this benefit will be less, because this is the opposite sign of this derivative here. For the VOC reductions, we also have mostly positive slopes or positive first order sensitivities, even over Lake Michigan, with mostly negative negative second derivatives. So we are looking at this case here, the top left case. So that means the VOC controls are also beneficial, and further controls will even be more beneficial. Now notice, however, that this area over the Lake Michigan off the coast of Chicago, we have a slightly positive second derivative with respect to VOCs. So that area, positive slope with positive second derivative, is actually this case, the lower left case. So additional VOC controls there have a decreasing benefit.
Hey,
But
Todd,
then, yes.
Sorry, this is just for one day, right? This is just one day as an example?
This is just June 10th.
Yeah, thanks.
It may be different on a different way, different day. And then recall that this sensitivity, cross sensitivity, was negative. So we are looking at a case with decreasing benefits when you apply VOC controls. But if you apply concurrent NOx controls, that's gonna actually give you some additional benefits. So it will actually pull this curve more to the towards the bottom, giving you more ozone reductions with additional VOC and NOx controls. So I hope this is clear, but it's really complicated. And what we've done is actually to take those first order and second order and cross second order sensitivity and put it in this formula. This is, you may recall this again from calculus as the Taylor series expansion. We call this the reduced form model. Since we have these sensitivity coefficients, we can apply this formula. And this is your current ozone concentrations at the current emissions level. So you can plug in your emission reduction levels, and calculate what the ozone concentrations are going to be when you change the emissions. So we're going to apply this formula to construct ozone isoplats, as well as to calculate the future design value. All right. So I'm going to give you several examples. So we have these for each site and for each day. But, okay, I should say for each day with high ozone concentrations, because we didn't really pay too much attention to the low ozone days. So this is at the coastal site within the Chicago non-attainment area. Site ID, and I believe it's called water plant. Angie, by the way, we double checked this site. It is called water plant. There's another water treatment facility, I think further down south. Anyway, and we are looking at June 19th. The observation on this day was 74 ppb, and the simulation was 73 ppb, which means, you know, we have a lot of confidence in what we have modeled. So here on the top right, we have the MDA8 ozone isoplats. Now we drew a line here, the blue line, for the control path that we suggest. So this is going to be close to the optimal control line. But to find the optimal control line, you actually have to find the steepest descent from this corner here. This corner represents, the 100% VOC and 100% NOx emissions. So NOx emissions on the y-axis and VOC emissions on the x-axis. So you have to find, the steepest descent line to each contour level to find the optimal control path. So we are not doing that. We are directly going to the 70 ppb isoplat. And, that actually corresponds to a NOx to VOC reduction ratio of 7:1, or maybe 8:1. So what that means is reduce your NOx emissions by 8 and your VOC emissions by 1 when you're doing that. So that's going to take you to 70 ppb in a near optimal fashion. We also have some charts at the bottom. So these are the sectoral emission results, the emission sensitivity results. So what this shows, for example, by the way, the positive N is going to be a benefit, a reduction in ozone if you reduce the NOx emissions. So the non-road, on-road gasoline, and other point, this is the non-EGU point emissions, will give you more benefit than the other sectors. But, the EGU, on-road diesel, and other point sectors also have benefits, just at a lower level. Now, don't pay too much attention to the second derivative, which is negative here. It's a little complicated to explain that, but actually, the fact that you have a negative second derivative indicates that you have additional benefits from NOx reductions. You have an increasing benefit. So you have to go all the way to the reduced form model, the equation in a few slides back, to understand that, the meaning of that. All right, and then we also have these time split sensitivities here. So what this is saying is, before I go to that, the yellow lines, those are the sensitivities to VOC emission reductions. So as you can see, you also get some benefits from VOC reductions, but not as much as the benefits of NOx reductions. All right, and then the time split sensitivities. So this period, for example, the late AM, that period is when reductions from on-road gasoline and non-road sectors, as well as on-road diesel sector, have the largest benefits. And then, this is, for instance, interesting, this turquoise color, which is the non-EGU point emissions. So the largest benefits from that sector can be observed if, the NOx emissions from that sector are reduced in early morning hours. So we have a plot like this for each one of the sites on high ozone days. I'm not gonna have time to show you everything. I'll show you a few more examples, but before I do that, we have a spreadsheet actually. So for this same site, the water plant site in Chicago, we started from 40% NOx and 5% VOC reductions. Remember, the suggested near optimal path was the ratio of 8 NOx to 1 VOC. So we started from 40% NOx reduction and 5% VOC reduction. We made some changes, for example, to the on-road diesel sector. We only reduced it by 30%. And we didn't apply any VOC reductions to on-road diesel or to EGU because those were not very beneficial. And also, this is the other non-point sector, 30%. So this is the numbers that you see in red is the portion that you can play with. So whatever you think is feasible, maybe these numbers are not feasible. You cannot reduce EGU emissions by 40%. So you can change this to 30% or whatever you can afford, but then you have to play with the others. And then this spreadsheet essentially calculates the future design value for that control scenario that you have created. So in this case, these numbers were able to get us to 70 ppb. All right, so the same non-attainment area, but the same site on a different day, this time on August 4th, and then a different site, actually, the Cook County trailer, which was further inland, on August 3rd. So those are very different than, this day, this site, water plant site on June 19th, when, we were suggesting essentially NOx controls. So the same site on a different day, the suggested control is about 1 NOx to 1 VOC. And then at the Cook County trailer, actually, VOC controls are favored by a ratio of about 8 VOC to 1 NOx. And then you can see how the different sectors, VOC reductions from different sectors are more or less effective. So the non-road, on-road gasoline, volatile chemical products, VOCs from VCP sector, and the non-EGU point sector, those are all effective. Perhaps the on-road gasoline is most effective. And actually, you can see here a negative first-order sensitivity to NOx, which means NOx reductions from the non-EGU point sector are disbeneficial on this day at the water plant site. At the Cook County trailer, same thing. So the NOx reductions from the non-EGU sector are disbeneficial. So these two sectoral split is pretty much the same. Excuse me. So the same non-attainment area is actually a third group of sites, which we call the far north. So if you look at the Chiwaki Prairie site, for instance, on July 20th, the observation is 80 ppb, simulation is 78, but again, very close. So we have confidence in this result. We see a control path that is about 1-to-1 and maybe VOC a little bit higher than the NOx controls. Now, both VOC and NOx controls are beneficial from these sectors, non-roads, on-road diesel, on-road gasoline. But as you can see, the yellow portions of the stack, which corresponds to VOC reductions, those are more beneficial. And then the time splits are interesting. So the biggest benefits from the on-road gasoline sectors are experienced in early morning hours. But the non-road sector, the late AM reductions of VOCs from that sector are more beneficial in late morning than early morning. So these are all, very interesting results. And then, the same Chiwaki Prairie site on 2 different days, June 25th and August 4th, have a totally different control paths. NOx controls are favored on this day, and VOC controls are favored on this day. And actually, on this day, August 4th, you can see that the non-road VOC controls are, sorry, this is blue. The NOx from non-road sector, if controlled, is disbeneficial. Similarly, the non-EGU point source NOx controls are disbeneficial. All right, so 3 more locations. How are we doing on time? This is taking longer than I hoped, but let me quickly show you.
Yeah, we have another. We're going to run until 30 minutes after the hour, so 12:30 Central. So I think you've got some more time. I want to see your analysis of a couple more of these non-attainment areas.
Yes. Okay. So first we have Cleveland, Ohio, non-attainment area, and we're going to look at the Eastlake site on July 21st. The suggested control path is 4 NOx to 1 VOC, or maybe 5 NOx to 1 VOC, somewhere there. And as you can see, NOx controls from non-road, on-road gasoline, followed by on-road diesel, and the EGU sectors are all beneficial. As far as the time periods are concerned, the non-road emissions are most beneficial if they're reduced in late morning and early PM hours. Same thing for on-road diesel emissions, and on-road gasoline emissions. You also have some sizable benefits from controlling on-road gasoline in late afternoon. All right, so next we have Detroit. And we're going to look at 3 different sites. On this slide, we have East 7 Mile right here, but we're also going to look at Port Huron and Oak Park site in the next slide. So this East 7 Mile site on June 19th favors NOx controls by 5 NOx to 1 VOC or 6 NOx to 1 VOC, somewhere in between. And as you can see here, the most beneficial is non-road NOx reductions, followed by on-road gasoline, and then non-EGU sectors. But all these sectors, EGU, on-road diesel, and other non-point are beneficial. And the largest benefits, remember, were from the non-road. And if you look at the periods on the dial, then early morning, late morning, and early afternoon are all beneficial for reducing the non-road NOx. All right, so moving on to the other sites, Port Huron and Oak Park. Port Huron on August 10th. So the observation was 73, simulation 73, right on the nose. So we are confident of this result. So this day is actually suggesting or favoring NOx controls again by a factor of 2 to 1 or 3 to 1, as you can see in this line. But we go to Oak Park, still NOx controls heavy, but the portion of VOC controls, should be increased. So, and you can see it here. For example, this is for the Oak Park site, the bottom right stack bar chart. So you can see a larger fraction of the yellow, which is the VOC controls. At Port Huron, the most beneficial sectors are non-road and on-road gasoline, followed by non-EGU point. And at the Oak Park, the largest benefit is from the on-road gasoline, followed by on-road diesel and non-road NOx emissions. All right, so last, let's take a look at Western Michigan, Allegan County, non-attainment area. So the site is Holland. On June 10th, the observation was 85 ppb, and the simulation is only 74 ppb at 11 ppb difference. So we don't have as much confidence in this result as we had to the other ones. But this on this day, NOx controls are favored with a ratio of 4 to 1. And then again, on the sectors, non-road is more beneficial, followed by non-EGU point and on-road diesel, and finally on-road gasoline. And on the dial, the largest benefits were from non-road in the late morning and early afternoon hours. So I hope you get an understanding of how we arrived to these conclusions. So we have a conclusion for each non-attainment and maintenance area. So we looked at a number of sites and a number of days with high ozone in each one of these areas and suggested an optimal control path. It can either be a NOx control or a VOC control, or in some cases it's both. And then we also identified, which sectorized emission should be reduced. I mean, which sectors result in most benefit, and also on the dial, we determined the periods during which reductions from those sectors would be most beneficial. So I'm going to leave it up here for you to peruse. Maybe you want to look at your non-attainment area of interest. So of course, we're going to provide you with the whole suite of isoplats and bar charts for all the receptors in your non-attainment area. And then my final slide is the rest of the non-attainment areas. I mean, maybe to summarize, I should say that both NOx controls and VOC controls are effective. Mostly NOx controls, but we cannot leave out, the power of VOC controls. And in many cases, we have observed that NOx and VOC controls are equally effective. And then the sectors are variable. We cannot point to a single sector for all these non-attainment areas. But probably, one can identify, the sector that is most beneficial by studying all these results. And then typically the early morning and late morning reductions turned out to be more beneficial than other times on the dial. So that's all I have. And I would be happy to take your questions. Here's my email. You can also contact me by email. Thank you.
Thank you, Talat and Young Tao. This summarizes a lot of work and a lot of complex work that you guys put into this project. Any questions from the LADCO members on the line?
Zach, is there like a write-up that we will be able to have access to or be able to cite or review of all this work in addition to all the the isoplast and interactive stuff?
Yeah, there's a final report. These slides just kind of summarize that final report. So there's a comprehensive report that includes like examples, walking you through kind of the interpretation like Talat showed here, and then a ton of plots. And then there's that spreadsheet that also lets you play with different reduction scenarios based on the results, the reduced form modeling results that came out of this project.
Zach, I would just, if you would feel okay, maybe just sharing what you feel about what you see here, and how it relates to the other work that you and your team have been working on over the past year, in terms of kind of looking at various sensitivities, and the brute force runs are just done and things like that as well. I mean, what's your takeaway when you see these results?
So, Talat and Yongtao used the same model system that we've been doing our runs on, the Camp 2016 based CAMX runs with our same meteorology, the 4-kilometer meteorology. They're internally consistent. So their results are consistent with what we've seen and with the analysis that we've done, which is good, and also kind of not surprising, because it's based on the same model. I think that this project lends a level of additional kind of specificity to the controls that I was hoping, to the different control scenarios that I was hoping to get out of it, beyond what we've been able to get from our brute force modeling and analysis. The reduced form model lets you basically run through different levels of controls, of NOx and VOC controls at different levels for different sectors, to try to get to 70, basically, at a non-attainment area. And we don't have that type of reduced form model available from any of the runs that we've done. So this is the added tool, the added decision support tool that comes out of this project. The specificity of the time splits and the different parts of the dial, I think, are really interesting. I don't know what we do with that from a policy standpoint, but you could see where, like, Chilwaukee Prairie was most impacted by emissions reductions that were happening in the early and kind of late morning, where Chicago and Cincinnati or Cleveland, you were seeing impacts more in the late morning and early afternoon, closer to the peak photochemical period. To me, that indicates, not surprisingly, the impacts of transport at Chilwaukee Prairie, where the emissions that were happening earlier in the upwind areas are impacting ozone at Chilwaukee. Some of the surprising things that I think I saw are, the impacts of VOCs. We've been saying all along that we think it's a combination of NOx and VOCs, particularly in the northern parts of our domain. And I think this project shows really what the impacts of the VOC controls are and can be in those northern parts of the LADCO domain. There's a lot here, David. And I think Talat has done a really nice job, and Yongtao, in summarizing it in the report and helping us understand how to interpret this information. We just need to now sort through it and see if we can really wrap our heads around it, because it's a very powerful tool, a little bit complex to understand. The idea of the second order sensitivity giving us a sense of how much additional emission reductions will either continue to decrease ozone or start to table off, I think is an important facet of this work as well. So that's kind of my initial take on this. I've read through the draft report. I haven't looked at all of the plots, but I would like for you all to start to work through the plots as well, and then we can kind of talk through different policy scenarios and thinking through how this work may support or help us think through those scenarios. I hope that helps, David.
Yeah, it does. I appreciate that, and I'm sorry, I should have thanked the crew that worked on this for an excellent presentation, and I know it was a ton of work, and that clearly came through today. And thank you for walking us through it today. It's very impressive. I guess my other question might be to the representatives that are on the line today, and what they think about some of this as well, particularly in light of there's transport proposal out there right now that is limited to NOx reductions, and we have increasingly learned through some work here, this being the latest example, that in some key areas here in the region that are anticipated to be in non-attainment for a while, the chemistry might not be quite that straightforward. So I don't know, Sarah, or anyone on the line, do you guys have any thoughts on what you saw here? Or is there something that you feel like, how do we get this into the right folks, EPA's hands, to sort of consider this latest research and information in their decision making?
I'm going to defer to Jenny.
Hey, good afternoon. This is Jenny Liljegren. Yeah, first I just wanted to say thanks a lot for the presentation. Nice work. I did meet you several years ago at a conference in Madison, and I think this is really nice. Yeah, David, to speak to your question, I guess the results that I've seen presented here today, I think are consistent with other sensitivity studies for the areas in question. And yeah, generally speaking, sounds like NOx emissions reductions are kind of the most important, but also for the areas that are transitional, like the Chicago area, additional, VOC reductions or a combination of NOx and VOC. So yeah, and in this study compared to the previous sensitivity studies kind of goes into a little more detail for the Region 5 non-attainment areas and the sectors and the time periods. So I think that's really nice. It sounds like it'll be really useful to the stakeholders on this call. I don't, obviously I can't speak for EPA headquarters or higher up, but I wouldn't foresee the agency doing anything more than like NOx controls for transport, because it's a national issue, and they're looking at like more long range transport historically with that rule. Not an expert on the transport rules, but yeah, I guess I'd be surprised just personally if from a national perspective the agency started to look at VOC controls. But I think in individual non-attainment areas, having this information is really important, especially for multi-state areas, because I think it allows the states to kind of look at how they want to do the combination of NOx and VOC reductions. So from that perspective, I think, yeah, this study would be really, I think will be really useful to you all as you're kind of planning or working on your attainment plans. So yeah, thanks again, Talat.
You're welcome.
So Jenny, I'll put you on the spot maybe for a bit of a follow-up in that, obviously we do this work for our own benefit, but also to kind of inform the national understanding of these issues, and we generate research and science for the benefit of everyone who needs to use it here. It's involved in this work. So is there, yeah, I guess EPA did in transport rule do a little bit of analysis to support their conclusion that it made most sense to focus on NOx emissions for the purpose of that proposal. Again, with some of this information being relatively new and not available to them, I guess, what is your recommendation then of how we get this in front of the right people there and kind of get this into the record so they can consider this information to see if it's consistent with their prior conclusions?
Yeah, I mean, I think that's an interesting question, David. I don't know quite how to respond to that. I guess I would defer to my colleagues, but I will say, like, there are folks that at EPA, like in OEQPS and ORD, who are aware of ozone sensitivity studies for the country, and aware that they're, while most areas are NOx sensitive and would continue to benefit from NOx emission reductions, that there are some kind of those lingering transitional areas that would need more NOx emissions reductions to get kind of over that hump, right? So there's be like a temporary disbenefit before you kind of get over the over the hump there. And while you're trying to do that, that a combo of VOC and NOx emissions reductions would be useful. But that's, yeah, really all I can say on that.
Well, Zach, I know you've got colleagues and stuff within OAQPS as well, and I'm sure they're also aware of some of the work we've been doing here, and you have some ideas on maybe how to get some visibility of this work to them.
Yeah, let's talk about this in the TOC. I have some ideas. Angie and mostly Angie, but Angie and I are working on like synthesizing all of this work that's been done on kind of research, both at LADCO and funded by LADCO and our members over the last couple of years. And so, maybe it's putting that all together and submitting that as a comment at some point. If we could get the air directors to agree on that, we're not going to be able to get it in, I think, for the comment period for the transport rule, which I think may have just been extended yesterday. But regardless, we won't be able to hit that deadline. But I think we need to talk about it internally among the states here, David, and figure out the best way to communicate this, because yeah, the transport rule is an attempt at a one size fits all rule across the country, and it misses the fact that some areas, and particularly some of the key, more vexing areas in this region, need to have some VOCs in the control suite as well. And the VOC control is not just from VCPs, from transportation, which, what does that mean? For on-road and non-road, it's like electrification. I think that we also need to kind of talk through what that means sector by sector. What does the VOC control look like for non-road and on-road, right?
Right. Yeah, this is good. And transport rules is an obvious one to kind of talk about because it's in front of us right now. But I think I'm really interested in, we cumulatively among the states and even as individual states in some cases have been, funding this work. And Zach, you've been and your staff done an outstanding job of coordinating and making this work happen. And, we're advancing the science on ozone. I just want to make sure as some of these products get wrapped up and we're learning a lot, that this is just getting in front of the right people, not just here within the region, which it is already, but with the right people at EPA, and that we can use that. They can use this and know it's available, and as they're making decisions. So thanks. And thanks, Jenny, for your responses as well.
Any other questions or comments for Talat? All right, well, thanks, Talat. Well, we've got about 10 minutes. And Angie, do you think you can cover your slides in 10 minutes, or do you want to maybe kick this to the next call?
I can cover my slides in about 20 minutes, which obviously I don't have. Why don't I just give a teaser? I'll skip over some of the slides, but I can give you guys an idea of what I've been doing. And then, as Zach kind of mentioned, we're working on a report on all the ozone chemistry work. We've been doing ozone sensitivity work, and that's actually, I'm aiming to have that out within a month or so. So you guys will be able to read more about this soon. So yeah, let me just give you guys a teaser of what I've been doing. So what I've been doing is basically looking at, can you guys see the slides?
Yep.
Okay, great.
Yes.
And full screen now? Is that the right mode?
Yes.
Okay, great. Basically looking at ozone trends in space and time, and trying to look at both what we expect to happen with ozone in the future, and also getting at this question of ozone sensitivity. And basic idea is you're taking advantage of the fact that NOx emissions tend to decrease away from city centers, and so that's means that basically we're going to have ozone reacting, and as we were just kind of saying, but ozone's going to react in different ways to NOx reductions based on whether you're in the city center or farther away from the city center. So basically, as I said, I'm looking at ozone changes over time and also over distance, and trying to ask both the questions about how ozones change over time in different areas, and how do we expect it to change in the future. And this actually came out of work I did when I was at the state of Wisconsin, where I was looking at ozone around Lake Michigan and realized that we had some really big, our northern areas along the lake were having really big reductions in ozone continuing, whereas the closer and closer you got to Chicago, the smaller those reductions got, and then actually the trend started reversing, we're getting increases. So I wanted to dig into this for years. But then also looking at what can we infer from these changes about ozone NOx VOC sensitivity. And basically what I'm doing, the approach I'm taking is looking at distance from the city center, and I've binned it in these 10-kilometer bins. But if you look at the NOx concentrations, this is from a model, but if you look at the NOx concentrations, you see NOx decreases, or NO2 decreases nicely away from the city center. If you look at NO2 concentrations over time, these are from monitor values, we also see NOx decreases over time. So we basically have two different ways of looking at the impact of NOx reductions. We have distance and we have time. But of course, there are also VOC changes that are going to complicate the picture somewhat. But just to give you guys an idea of what I've been doing, you guys have seen this figure before. I showed this for weekday weekend. This is a plot showing how ozone concentrations change. It's related also to what Talat was showing, how ozone concentrations change with NOx concentrations. So as NOx, if you start off VOC sensitive over here, as you decrease NOx, your ozone is going to increase. You reach a peak ozone levels when your chemistry is transitional, when it's responding to both NOx and VOCs. And then as it becomes NOx sensitive, you have these reductions. So what we have here is we're going from high NOx to low NOx. This is actually high NOx to low NOx here. So if we just flip this figure, now we're looking at high NOx and low NOx through the same kind of curves. And then what we can do is we can look at, we have this VOC sensitive over here, transitional NOx sensitive. We can look at how ozone is responding as we go away from the city center, going from high NOx to low NOx, and also how it's responding over time, and kind of get at which of these regimes we're in. So the idea is that, if you're VOC sensitive, if we're in this part of the realm, as your NOx decreases, your ozone is going to increase. So we're going to have increases over time, increases over distance. But VOC reductions may complicate that. Transitional, we're going to be at peak ozone, both in space and in time. And then NOx sensitive, we're going to have reductions in ozone as you go away from the city center and over time. What I have, I'm just going to quickly show some plots for St. Louis and for Chicago as some really different examples. So this is a map of St. Louis in 1991-95 with ozone. These are fourth high values, mean fourth high values over this 5-year period. This is a 6-year period, 2016-2021. And this is the city center. I define city center as the location of City Hall, which actually coincides with the areas of highest NOx as well. And what you see is back in the early 90s, we had the lowest concentrations right near the city center, the blues, and the highest concentrations outside the city center. Whereas if you come at this latest time period, very uniform concentrations. We don't see this big change over time. And the kind of the bullseyes are, each line is 10 kilometers away from the city center. So this is 50 kilometers, this is 100 kilometers away. I then bin things based on into these 10-kilometer bins. And this is ozone fourth high values in both plots. This is distance from the city center. This is time. So again, both of these are going from high NOx to low NOx, high NOx to low NOx. And what we see, if we just focus on the red line here, the first set of years, you had really low ozone at the city center, and it increased away from the city center. And then now, if we look at now just the city center, the inner 10 kilometers, we see that had low ozone, it increased over time, peaked, and then declined. So we're looking at basically VOC sensitivity here, changing to transitional chemistry of our peak ozone here, and then NOx sensitivity here. Another really interesting thing is that, and if we're looking at farther out away from the city center, like out in 80 to 90 kilometers, you see just, bam, it's just decreasing nicely. So we're basically responding to NOx reductions that whole time. Another interesting thing is if you looked at spatially, in the early 1990s, when this record started, we had the lowest concentrations in the city center, and highest were kind of 30 to 60 kilometers out, whereas now we have highest concentrations in the city center, decreasing away from the city center. So Chicago's really different. If we look back in the early 90s, we definitely had lowest concentrations in the city center, highest concentrations out, about 60, 70 kilometers. Chicago is also complicated because, of course, we have the lake. And we know the lake is driving, Shiwaukee Prairie is the highest, but it's also partly highest because it's 150 meters away from the lake shore. So we have the lake in addition to chemistry. But if you look at the latest set of years, they're not that different. St. Louis was really dramatically different. The city center is a little lower generally, but we had some light blues here and we have some light blues here. Not as dramatic a difference, except the outlying areas are much lower concentrations. If you look at these trends over time, if you remember St. Louis, we had this really big increase and really low values in the city center increasing sharply. We don't have that in Chicago. We have a kind of central area that's really like low NOx or low ozone, really suppressed and increasing outside. And that pattern's kind of steady, although if you look at the red line, the early 90s, it's a very big difference between the city center and the outlying areas. If you look at the blue, the latest period, there's a little difference. There's not, the differences have changed a lot. The curves have flattened, basically. There's not as big a difference. And then if you look at the trends over time, this is VOC sensitive area. This is NOx suppression, titration, central city. And we had again, the reds are the center of the city, pretty flat ozone in the first time periods. There's a really big drop in the mid 2000s. This is when the NOx SIP call came to effect, Tier 2 vehicle standards. But then we have a shift to transitional chemistry here. We have increasing ozone over the last decade, 15 years, increasing ozone in most of the Chicago area. I'm just going to leave that there. I'm basically out of time, but also looking at recent ozone changes last decade, we see increases. Purple is increasing ozone in Chicago, decreases everywhere else. So I'll just leave it there, other than to say that, I'm working on this report on ozone sensitivity. There's 5 different new sections. You guys have heard about these before: ground-based ratios, satellite model ratios, weekday, weekend, and this section. These are all written. So this report is well on its way to being completed. I need to write up this section and then write up a synthesis where we compare all of these. This will also compare with the Georgia Tech work. So anticipating finishing that in a month or so, and then the overall synthesis report, aiming for late summer. So I will leave that there just because of time, but would love to take any questions if people have them. It's basically a different way to try to answer similar questions, but then also looking at the spatial trends.
We can dig into this some more on the next call too.
Sure.
Looks good, Angie.
Thanks.
Talat, thank you so much for your presentation.
You're
Great
welcome.
work to you and Yong Tao. I will circulate their products, which will be finalized in the next, I think, week or two. We'll send the slides around with the notes for this call. We are working on the technical support document. I know that I've been trying to get this out to you now for about a month. Had a little bit of a delay this week with some staffing issues at LADCO and not being able to put the work on it that we wanted to. But I'm thinking that we'll be able to get you guys a draft. I know I keep kicking it back like a week and a week and a week, but I think we'll be able to get you a draft next week once we have these staffing issues taken care of. So thanks everyone for your time. I'll send around some notes, a link to this recording, to Lot's slides, and like I said, his final report once it's ready. Thanks to everyone, and I hope you have a great rest of your day.
Thanks, Zach.
Thank you.
Bye.
Thanks.
Everyone.
Be great.